Okay, for this video what we're going to do is we are going to graph a parabola using the vertex and the intercepts. There are some key features that you can identify right away. The first thing that you want to look for is to figure out whether your graph opens up or down, and it all depends on the leading coefficient or the value in front of x squared. So if the term in front of x squared is positive, it opens up. If it's negative, it opens down. So we can see from this one that we're going to open down, which means that our graph will have a maximum point. The maximum point is just going to be the vertex. The second thing that we're going to find is the vertex. And remember that when you are finding the vertex, the coordinates are always going to be at negative b divided by 2a, comma f of negative b divided by 2a. So in order to find the x coordinate, you're going to use the negative b over 2a, and then to find the y coordinate, you simply plug in the negative b over 2a back in for x. So what we're going to do is, if you recall, a is always the value in front of x squared, including the sign. B is always the value in front of x, including the sign. So our x coordinate of the vertex is going to be negative b, so we would do negative 8, divided by 2 times negative 2. So because we have an odd number of negatives, this will give me a negative value, and I end up with 8 divided by 4. So I end up with my x coordinate is negative 2. To find the y coordinate, we would just do f of negative 2. So when we plug that in, we would have negative 2. Make sure that when you plug this in that you do put it in parentheses squared, minus 8 times negative 2 minus 8. So if we simplify this, this would give us positive 4. Positive 4 times negative 2 would give me negative 8. So make sure that you don't distribute this negative in here. I see that a lot. I have students that will distribute this in because they think multiplication comes first, but remember that the squaring comes first, and when you square a negative, it becomes a positive 4 times a negative 2, which gives us negative 8. This part right here gives me positive 16 since I have a negative times a negative, and then I would subtract the 8, which ends up giving me 0. So my vertex is going to be at the point negative 2, 0. So I'm going to go ahead and graph that on my grid over here. Negative 2, 0. I am counting by 2's on this, otherwise it wouldn't fit on this grid and I would have had to create a different grid. So just to make it work, I'm counting by 2. So this would be negative 2, 0 would give us our vertex. We know it's opening down, so it's going to go this direction. So when we find our intercepts, we should find our y-intercept being a negative value. This point right here, we've already found the x-intercept, and whenever the vertex is directly on the x-axis, that means that there's only going to be one x-intercept. So like I said, we already found the x-intercept because this one happens to be the value when y is 0. So if I would have solved this, just to show you that it does give me the same thing if I were to find the x-intercept by plugging in 0 for f of x. So if I plugged 0 in here, just in case you have this situation, or you have a situation where it doesn't happen to be the vertex, what you would do is you would just replace the f of x with a 0, and then you would write everything else, the negative 2x squared minus 8x minus 8. And then to solve this by factoring, the first thing that we would do is take out a negative 2. And I'm just going to switch sides, x squared plus 4x plus 4. And basically where this came from is I just undistributed a negative 2 from everything because they all have a 2 in common. I can ignore this because of the fact that it has an x. Basically, if I divide both sides by negative 2, this would cancel out if I divided 0 by negative 2, so I can just ignore that because it doesn't have a variable. And then I would look for two numbers that multiply together to give me 4 that also add up to be 4. So this would break down into x plus 2 squared, or x plus 2 times x plus 2. So we end up with x equals negative 2. So this repeats twice, so that would be multiplicity of 2, which is why we only have one intercept, because it's the same one. To find the y-intercept, again, remember that to find the y-intercept, all we have to do is find f of 0. So that tells me wherever I have an x, I'm going to replace it with 0. So essentially that first part becomes 0 minus 8. So we can see that our y-intercept is going to be f of 0, negative 8, or we could write it as an ordered pair 0, negative 8. So our y-intercept is going to be here. Because of the fact that this is symmetric, we know that on the other side it would do the same thing, so our graph would look like this. I forgot to address the axis of symmetry. Let me go back up to the vertex. The axis of symmetry, and we'll do it in yellow. The axis of symmetry is always the vertical line that goes through the x coordinate of the vertex. So in this case, it would just be x equals negative 2. So if you're asked to find the axis of symmetry, it's just the line that goes through x equals negative 2. So if you're asked to put the axis of symmetry, that's all you have to do. Basically, it cuts your parabola in half. So the domain and range are something that are typically asked for when you are graphing a function like this. Remember, the domain is our x values. Your domain for all parabolas is negative infinity to positive infinity, or all real numbers. The range is your y values, and if you notice, if I start down here with my y and I move up, I keep hitting until I get to 0, and then I stop hitting after 0. So negative infinity to 0 would be my range. If it asks for the interval of increase or decrease, and you may or may not have this question, this is something that sometimes shows up, so I'm just covering as much as I can in one video. If it asks for the interval of increase, it's looking for the increase, it's looking for all x values that show that y is going up. So in this case, my y values are increasing from negative infinity until I get to negative 2. So my increase would be negative infinity until negative 2. This is just the x coordinates for where y is increasing. And you always put it in parentheses. For decrease, you're just looking for your values where y is going down. So my y values are going down, starting at negative 2 all the way until positive infinity. Okay, so just to recap what we did, remember that if it asks you to graph using the vertex and the intercepts, to find the vertex, you're just going to use these points, negative b divided by 2a, comma f of negative b divided by 2a. We know it opens up or down based on the leading coefficient a. If it's positive, it opens up. If it's negative, it opens down. If it asks you for your maximum, the maximum here would be at the point y equals 0. Our maximum point is 0 on this graph, so that is something else that they sometimes ask for. The vertex is always, like I said, negative b over 2a, comma, f of negative b over 2a. Your x-intercepts are found by replacing your y coordinate with 0 or your f of x coordinate with 0 and solving for x. Your y-intercept is found by doing f of 0. And increasing or decreasing intervals always have to be in parentheses. As always, thanks for watching. If you have any other topics that you need me to cover, please let me know. If you have any questions, please let me know that as well.